What if someone flew into a black hole? Well, they probably wouldn't make it very far, but what would happen as soon as they entered the black hole? Once the person got close enough to the black hole, they would start to undergo a process known as spaghettification. But what is spaghettification? Say our astronaut Ben was near a black hole. First, he would feel a pulling sensation bringing him closer to the singularity. Soon, the effect of gravity would become uneven, pulling harder on one part of his body, like his head, than another, like his feet. This relative difference in the force of gravity is known as a tidal force. Ben would start to get stretched, more so the closer to the singularity he got. Eventually, Ben would turn into nothing more than a string of atoms, like spaghetti. Spaghettification is actually more likely to occur in a stellar mass black hole than a supermassive black hole. That's because the tidal acceleration of a supermassive black hole is actually smaller than that of a stellar mass black hole. If Ben were to approach the event horizon of a supermassive black hole, he might experience less tidal acceleration than he would if he were standing on Earth. On October 12, 2020, the Royal Astronomical Society released an article about a tidal disruption event, or the spaghettification of a star. It was the first time scientists caught it early enough to observe spaghettification in real time. They were able to use this information to calculate the speed of tidal disruption events and create simulations for further study. We're able to see through studies such as this one that while spaghettification can happen to anything that comes too close to a black hole, different objects experience it differently, and different sized black holes cause different tidal forces. So while we won't be sending any astronauts into black holes anytime soon, spaghettification and tidal forces tell us a lot about how black holes work. Eventually, with this knowledge, it may be possible to survive entry past the event horizon of a supermassive black hole. Until then, we're stuck looking from the outside in.